numbering different. It states, look at the picture above. And then cheesy little homework assignment. But I've had students say, oh, that's not what I circled for number one. And that's okay. But I do one thing that I see wrong for sure is eating in the lab while a lab is going on. You know, you know, yeah, in class right now we're not doing that. And there are things that possibly you lab. Well, right now we're not using. But anyway, I do know that when we have materials out, we should have I do see something else that's like not okay. Is this right here? Right, horse players, you know, don't get me wrong, we love to play around and stuff, but you know, the fact that they put it down causing like a fire is not too good. Another thing that I see over here is the backpack on the floor. When you go to the actual lab over here, a lot of them have backpacks on the ground. I love that we're in small classes. And even on campus, we're in small classes. We're just used to I think they got to have the class okay? And you might have to take backpack. But you've got space. You're going to, you know, we actually have quite a bit of space because we have such small classrooms. Here's something I see incorrect. Is it a purple that's on the flyer? How much can I look at? I mean, that's for sure not quote unquote fully back. So because we said what the world and then we found it. There's the big like red. Right? Other than that though, it says here though, I see that he is throwing incorrect things away in the wrong trash. Okay? When it comes to this stuff, you just want okay? And you just trash. Well, they like or the trash you like trash. Not what glass. The glass trash. So the trash is actually a broken glass. One building lies throw glass away that trash bin because they say they're right. So when they're picking up the trash bag or something like that, the last thing they need to do is pick up the trash bag and if they dig it or something, or there's glass in it. So that's really a big. The next thing over here, you probably heard of do not mouth pipette. The word mouth pipette is not sucking up with a straw. Like I need to do that stupid regular pipette. Someone says you want to take a baby medicine so it can suck up, but you need baby medicine. Here's what it is. And you know, you all suck up, right? You don't know what it is, or is it harmful? So at this moment, one, two, three, four, five, six. Here's one right here. Food left out or food. I will say that normally I are really good, but these are all that chocolate off and this body filled up with snacks. You know, you guys do. Here's another thing. I will tell you that I've always been a mother. Most kids love me or might have left class before. Most kids don't like spilt over or whatever it is. Another thing that I see over here is that this kid is on fire. All right. And don't get me wrong, this kid is also and this kid is also on fire. Being on fire, you've got to get those something. You put somebody first or you try to put I mean, now that's not the public right? The public what you were to do. You were to circle those, and then you were to number them, and then you were to say what's going on. So I said it out loud. I'll go ahead and post my answer sheet that I have, which might be a little different than yours. All right, easy cheesy. Then on this side, homework number one again. On homework number one, that's a video. All the video homework. Okay, I'll post it, but you probably watch the video. You probably pause it. So I will definitely post those answers. Other than that, it goes into homework number two. Homework number two, don't forget to do this one today at 8 a.m. It's a video, so take your time today to watch the video if you haven't started it. And then homework number two goes into an MSDS. Anything that not anything on the it's what we call it questions using MSDS at the bottom below. Nitrate acid is what it is. Okay? Nitrate acid. What is the name of the substance? I know this is your homework, but I mean, let's do a couple of questions together. Nitric acid is what the name is. It literally says chemical name right here. What phase does your substance exist at room temperature? So if you were to be there in the classroom, would it be a solid, a liquid, or a gas? Solid, a liquid, or a gas at room temperature. So when we come over here and look at our MSDS sheet, and all MSDS sheets look a little differently. Okay. Some of them are one page, some of them are 2 pages, but they try to keep it into one page. So looking at this chemical over here, it tells me specific gravity, the molecular weight of it, the formula. Keep going through it. I see that it is transparent, colorless, or it could be a yellowish liquid color. Okay, so I do see the word liquid. I'm just going to circle the word liquid right now. It doesn't tell me at room temperature, but it does say liquid. It says that it's poisonous, severely corrosive to all body tissues, meaning that if it spills on you, it's going to, dissolve your skin. It's going to be like an acid that's going to burn through a hole through your skin. Okay. It also says here there's fire hazards. It's non-flammable. Oh, okay. But it's a strong oxidizer. Remember we talked about that word oxidizer? An oxidizer is going to remove electrons from another substance, kind of like rust. So it breaks it apart. Okay. It says here dangerous fire risk in contact with acetic acid, meaning that it's not going to catch on fire with fire, but if you put it in another acid, that sucker then, boom, catches on fire. Yeah, it says here combustible or organic materials. When heated, it will emit toxic fumes. Snap, we better do this in a fume hood. We don't want to inhale this because there's toxic fumes. As I continue to look over here, talks about the spills. It also talks about here store it, this acid in an acid cabinet away from any source of water. Oh, they don't want this stuff to be on water. Okay. You use it. Oh, that's what I said. And then talk about so at this moment, the only people that I see at this moment is that this sucker is a liquid. Right? It says also go ahead and list a couple of things that you're talking. Wait a minute. Talk about last week. Remember we had that diamond, that image of the diamond, right? And there were 4 like diamonds inside of this diamond. One was hopefully we remember the white one is this one down here at the bottom. The white one not only is it called the special one, but it's special because it can be left blank with nothing in it, or you can have more than one special type situation. So when you use it, you might use a couple of. I saw one oxidizer. Remember oxidizer? So you can write the word or you can put it. I would go and but I do see the word oxidizer in here, so I would definitely go ahead and pick that off there. Okay? Corrosive. Did you see that word also, like I did? Corrosive. So I'll probably go ahead and pick that word too. Alrighty, I'm going to go ahead and leave this homework alone because 3, 4, and 5 is for you. Plus, you've got to watch that video. I think y'all probably have time today to go ahead and work on that. Then we get into homework number 3. Let's move this out of the way and let's get back to notes. So I haven't started posting the notes yet for this class, but I need to. And remember, I told you I left them blank for you to fill in later on. I'm going to post those today after all my classes. Taking a glance at this real quick. Chemistry is the composition of matter. It's the study of the stuff that makes things up. And don't forget, all things are made up of atoms, right? And atoms are composed of electrons, protons, and neutrons. True story. It's not just those three options, electrons, protons, and neutrons. We actually were able to discover that there's other parts inside of an atom, but those are the three main, okay? And those other little parts that are inside the atom, we don't have full understanding of them just yet. We just know that there's something else in there. Maybe something some scientists call it. It's like a glue that holds it together, or like an energy that holds those atoms together. So we don't have a little bit. We need more understanding before we can go into our books and say, wait a minute, atoms are made up of 4 things or 5 things. We just don't have all that info yet. Then our notes go into safety, right? Which we've already probably talked about. Then we talked about, hey, there's questions. I did this one for you. I left this one blank for you to practice. Hopefully you did it over the weekend. And then it goes into safety. Don't forget, you that are very precise, a pipette, a burette, are very accurate, as well as a volumetric flask are accurate. Things that are not accurate, that are used to approximate, are going to be things like an Erlenmeyer flask or a beaker. Okay, just wanted to make sure I said that again. I did one answer here, and I left these 2 here for you to work on. Hopefully you did work on those already. And then I'm going to turn the page, and we started on MSDS. So MSDS is regulated by OSHA. OSHA is going to determine and say, hey, every chemical, every compound needs to have some type of MSDS. The MSDS is going to tell you what precautions you need to take. What PPE, which stands for personal protective equipment, like safety goggles or gloves. And then this OSHA determined this MSDS, it should have some good information on it. And because it's really hard to just print out for you to read it all, we have this NFPA diamond. One more time, this NFPA diamond. And so that NFPA diamond is a shortcut of that MSDS. Okay? Because that can get starting to get a little long. This is just the meat. I need to know careful this, and this kind of thing. Right? Then we came over here and we saw that the MSDS sheets or the NFPA diamonds are color coded. White stands for special, right? And then this one is what I call nothing in it. We just have more than one. But the blue can help, the red can go, the yellow will be white. They only have one number. That's it. The two and the number 3 and the number 4. The problem is when you start to read these keywords over here, like no potential, minor, dangerous, serious, and severe. Severe meaning like there's no going back. Death, right? There's no going back. Explosive, cancer, like it's severe. Okay? But these right here, number 1, 2, and 3, are a little tricky. I will tell you, we have this on a quiz coming up this Friday, and we're going to have this on a test, meaning an NFPA diamond, where you're going to read the MSDS sheet and you're going to quote unquote guesstimate. But remember, I'm going to give you some flexibility. If the real number is 2, I'm good if you put like a 1 or if you put a 3. But if the real number is 2, don't get to a 0 because that's too far off. nothing on there. It was something like water. Very simple. Then here are a few of these special codes. These are the main ones. Okay. Again, we can have more than one. And then I gave you a few other words. In the blue section, you may read words like this. In the red section, words similar to this. And then in the yellow as well, they have their own special words for reactivity. Then we went ahead and answered a couple of questions. And then we came over here and we looked at our MSBS sheet. And that one looks like a 3/2. Again, I will, if you do this on the quiz or test and put a 3/2, I will give you points. I'm great with that. I will give you points. Then we get into matter. I am so sorry, but unit number 1 is just a review from middle school. It really is. Don't get mad and upset. It's just pulling back all this information that you really did learn like a while back. Okay? So let me grab my notes out so that way we can finish Tuesday. It says here the definition of chemistry is going to be the study of matter and the changes it undergoes. It says here, let's keep going. They want to do more matter and matter. Well, you probably already know those. Matter is probably that basic definition. Anything that takes up space and has mass, right? That's like that basic middle school definition. So, what is the definition of mass? Mass is the amount of matter. The amount of matter. So, like when you pick up that object, is it really quote unquote heavy? If it is, then there must be a lot of matter that is shoved into it. There's a lot of matter shoved in, so we pick it up. Okay? Let's look at the word physical properties, and then we're going to come over here in a moment. We're going to look at the word chemical properties. There's two different definitions. So physical properties is not the same thing as chemical properties. So for physical properties over here, it's going to be physical properties are observed without, that's my shortcut of without changing the substance, meaning that it stays the same. What are we not changing? Well, we are not changing. We mean not changing the atoms. We're not going to rearrange them. The atoms stay the same. Stay the same formation. They don't move. They don't have a chemical reaction. The atoms stay the same. Now, when it comes to physical properties, there's actually two types of physical properties. And students kind of sometimes get this confused. I do too. The word extensive versus the word intensive. So one more time. We have extensive physical properties and intensive physical properties. Okay? When it comes to the extensive physical properties, that definition is going to mean changes with the amount. It's going to change when the amount changes. So extensive property means that it's going to change when the amount changes. For an example, let's say we have a 2-liter what changed when I pour everybody some soda out? The amount changed, meaning how much liquid is left. It's no longer 2 liters. Let's say now I only have 1 liter. So the quantity or the amount changed. Hopefully that makes sense. But intensive property, here it says it does not change with, oops, I keep trying to write an E, with the amount. Meaning that if I've got a big piece of water and then I have a small cup of water, the density of water is going to be one. And even if I had a 10, 15-gallon container of water and a little cup of water, the color is going to be the same. Whether it's a big piece of water or little small color, then it's the picture here, and you saw through there, not a guy in there with his pop the hair off, and they're going to hurt the color, right? So that's going to be an intensive property. I cover, I change the amount in this physical property stays the same. So when we take a glance at this over here, there's a couple of different type of physical properties. Is it going to be extensive or intensive? Well, you have to read the definition. But these are all physical properties: hardness, brittleness, elasticity, malleability, viscosity, and tensile strength. Well, believe it or not, we've got two more. Okay? Two more, and they just somehow did not get typed into here. Here's the other two. We've got luster and we have ductile. Okay? Those are the other two. They just didn't get typed in. That's okay. We can write them in. We're doing notes. We can write these. All of those are physical properties. Is it intensive or extensive? Well, now you have to read it to make that decision. Okay? Is it going to change when the amount changes? So let's go ahead and look over here. It says hardness is going to be how difficult it is to scratch something. For an example, a diamond is one of the hardest objects we have here on Earth. You can just bang that sucker all along or try your best, but it just doesn't really scratch. It's really difficult. It's really hard. It says here, a diamond is very hard because you can't scratch it, right? But compare it to a piece of soap. You have soap at your house? You just put your fingernails barely through that. That sucker's all scratched up, right? It's not very hard. Look at brittleness. The word brittleness, it says here, is how easy it is to shatter. How easy it is to shatter when it's dropped or struck. Like, for example, if I have a piece of wood and I drop it, I might like put glitter everywhere on the edge and all. And the wood itself probably move the piece of wood. But if I have it flat up and accidentally drop it, it's probably going to shatter. It's going to shatter very easily. Let's take a glance at the next one. The next one over here is elasticity. Elasticity is going to be how much something can be bent out of shape, but then it returns to it. You know, like erasers, you can bend those suckers and then let go and they go back. What about a rubber that's short? French? French? A scrunchie, right? You know, a rubber grip. You can pull it and then let go and it goes back to its original. It's meant to last. But malleability over there, the word malleability means how easy it can be pound into something else or to thin sheets, kind of like gold. We can get gold and we can melt it together and then we can hammer it down and we can have malleability. We can smash it down if we need to thin sheets of gold. Or let me give you an example. aluminum foil. Ah, how about that? That's pretty malleable. Viscosity. Viscosity is going to be how slowly the liquid pours. Viscosity only occurs in liquids. And it's kind of like shampoo or conditioner. Does that kind of like coming out? And you have hand soap and you pour the hand soap and it comes out with water really fast compared to slow or liquid. It's very viscous. It's very liquid and it pours slowly. Okay. Next one is tensile strength. Tensile strength is going to be how hard or easy it is to break something by pulling it. The key word is pulling. But whenever you have pretty strong. Luster. The definition or the word for luster means shiny. Is it going to be super shiny, polished, nice and neat, like chrome, like a chrome color? Or ductile is going to be how you can pull into wire, like, example, copper wires, right? So we can make it into thin little wire. You're going to pull it, or you're going to pull it into a thin wire. Okay? Let me give you an example. You ever got like toothpicks when they're hot, right? You break it off, or you take a bite of it, and you pull that tooth, right? And here's ductile. And it's like a wire, like a string. Think of it that way. Turn the page. Because we have another one. Another physical property over here is density. But this is a super important physical property. We're going to have to be able to calculate this one, and we're going to use this one throughout the school year. The density is going to be how compact, the word density is how compact an object is. Or how much atoms in that object. The more atoms that are smushed into it, the heavier it's going to be, more dense. Okay? The black atoms inside of there, like styrofoam, is going to be light, basically, right? Now, there is an equation for this, and it's going to be on our quiz this Friday. It's a super easy one. If you haven't checked out the calculation with one, you need to start to check out a calculator because we're going to start using calculators. But this is a pretty easy equation here. This equation is density equals the mass of the object over the volume. How much liquid it is. And this equation is shortcut equals D equals M over V. D equals M over V. This equals mass divided by volume. M stands for mass. And mass should be in grams, maybe even kilograms, but it should be in some kind of mass format. Density has an SI unit, and V stands for volume, and that has an SI unit. How much liquid, as in milliliters or liters? But wait a minute, this is a little different. Volume could be, is there any way, have you ever calculated the volume? This is milliliters. And you get an SI unit of centimeters cubed, a 3D dimensional object. or it could be meters cubed or inches cubed, right? It can be one of those. So don't forget that this over here stands for a liquid, and this over here stands for a solid, meaning that liquids can have density and solids can have density. So when I combine, look at this, mass is grams, and let's just pretend that it's a liquid, milliliters. Will those units cancel out if one is on top and one's on the bottom of the division? No, because they're two different units. So for our density SI unit, it's going to be, for an example, grams per milliliter. If we're talking about a liquid, or if we're talking about a solid, it might be grams per centimeter cubed. And that's okay, because when I'm looking at tools, those are liquid and one is solid. Okay? So we will be practicing some of that later this week. I'm going to keep going on because it's only 10:17. We haven't even hit a good hour yet. We definitely need to hit quite a bit of notes. Let's look at the word, chemical properties. So a chemical property now, we looked at physical properties. Now we're moving on to chemical properties. And so for me, I'm just going to highlight it in different colors, kind of dark. I apologize. Chemical properties, it says, is going to be, is observed by changing the substance. And again, just like earlier, what are we changing? The atoms. What is being changed? Changing the atoms. In this school year, we're going to talk about changing those atoms. They're going to have reactions in the current. Those atoms are going to distribute, and they're going to change the way that they are and what formation. They're going to break bonds, and bonds are going to it says here, for an example, we have Fe, which is on the periodic table for iron, plus O2, oxygen. And if these two suckers combined, we end up with Fe2O3, which most of us call rust. There was a chemical, this is a chemical property that occurred. Some things occurred with atoms combined to light. Sounds like a bicycle outside. So what happened is that these atoms from F and oxygen came and they manipulated themselves and they combined to form Fe2O3, or we call it rust. So let's do a couple of practice problems, okay? We just talked a little bit about density, and we just talked about chemical properties, the definition. Let's do some practice problems on density. Now, don't forget, the equation for density equals mass over volume, okay? It says here, I've got a 15 grams is mass, object that has a volume of 30 centimeters cubed. Find the density, question mark D. But my problem is, well, I do see something that I have that means that so for this situation, with your calculators, you probably already have, D equals M over V, or 15 divided by 30, probably can do that one in your head, equals 0.5 grams per centimeters cubed. All right, not bad. The next one, a 12 gram, okay, so this is mass still, object has the volume of, oh, well, that's a liquid because it's in milliliters. Find the density. question mark density. Density equals M over V. Thank goodness they gave me the M, which is 12. They gave me the volume, which is 6 milliliters. And this time I don't know but I can do the math, and my answer comes out to 12 divided by 6 is 2 grams per milliliter. This is what we're going to be doing on Friday. We're going to be doing this where I'm going to do a couple of objects and meaning we're going to have to go and find the mass in the scale, and you're going to have to find the volume. If it's a solid like example number 1, I'm going to do that more and if it's a liquid, so that way you can figure out the volume. Okay? There's a special one that we'll talk about as well on Friday. It says here that 35 milliliter object, okay, so milliliters meaning volume, okay, they start off with the volume first, of an object has this density of 2. Find, question mark, the mass. Oh, so now we need to do a little bit of algebra. Y'all's algebra skills should be pretty okay. D equals M over V, or density is 2 grams per milliliter. My mass was not given to me, question mark. My volume is 35. Basic algebra skills, I have an unknown variable, which is okay. I can solve for that. If I multiply this side by 35, cancel. Multiply this side by 35. And this right here, 35 milliliters. And algebraically, you can see that the milliliters are going to cancel each other out. 35 times 2 equals 70. And what's left over? This unit, grams. And we're looking for mass, so grams is the correct unit. So just algebraically solve. When you're ready, turn in the page. Now on Friday, our lab is mainly over density, okay, is what we're going to do, as well as take that quiz, okay? And then you have a little density situation that you need to do before you leave. Then after that, you can go. This right here, it's a really good practice problems. I'm going to leave this situation for you to do. And what I will do, though, is I'm going to go ahead and box this in. I will go over some of this the next time we have class. But let me practice. We're going to match. For an example, it says over here, hardness. Hardness is going to be the measure of how easy a solid can be. Is it scratched? No. Is that density? Is it? Oh, yeah, that is hardness. Scratched. There you go. I was thinking of brittleness. Let's look at the next one. Let's look at elasticity for an example. That's going to be how easy a solid, not poured, is it measured on its ability to return to its original shape? Yeah, elasticity. So we're going to match those. And then there's going to be some density equations. And for an example over here, when building a bridge, engineers want the bridge cables to have a great amount of tensile strength. Why? Because we don't want those cords to snap. We want it to be able to stretch. Glass can be scratched by quartz. Which one is harder? The quartz. Because glass is scratched by the quartz. It says here, lead feels very heavy for its size. That means that lead is very dense. So you're going to use those vocab words from the previous page to answer this. Not bad. Now we're going to come back over here and we're going to finish this page off, and then we can be done for today. And then On Wednesday, we're going to talk about solid, liquids, and gases, which is easy. And then we're going to come over here and talk about how matter is separated as well. And then we'll talk a little bit about separation techniques. We're almost done with the notes, believe it or not. So today and Wednesday, we're going to knock out most of the notes. Here we go. Friday, we'll have a lap. Okay. Let's talk about changes. We've got, wait a minute. Earlier today, we talked about physical properties. Now we're going to talk about physical change. Okay? Physical properties means that when you change the amount, it's not going to change. It stays the same. But a physical change, like, let me go back to the same color right here. A physical change means that the identity of the substance does not, it has not, that's not involved. So physical change does not involve a change in the identity of the substance. Meaning that it's still the same. So if I do something, if I do anything here, the atoms are not going to change immediately. Remember, when we talk about that word change, we're talking about atoms, those electron protons. It's going to be, you definitely need to know those symbols over here as well, so we'll talk about those. But let's go into some examples. Miss Munson, give me an example. What are you talking about? I'm talking about, what if I have an ice cube and I melt it? That's a physical change. Water, liquid and water ice is still H2O. I never changed the atoms. What if I smashed it? What if I had a big thing of Play-Doh and I smashed it? It's still going to be Play-Doh. It didn't turn into gold. What if I cut your hair? What's your haircut? It's still going to be hair. Your hair didn't change the color. Nothing major happened to it. Another example would be, have you ever gone, I don't like it, sweet tea? Those people who drink sweet tea are going to dissolve sugar into their cup. It's still sugar, and not only that, but the part of but it's still sugar inside of it. Another one would be, believe it or not, crystallization. A lot of people don't believe this one. Crystallization. Forming crystals. It's still the same atom, but now they're becoming a bigger solid atom. Let me give you an example. The rock cube, okay, also known as the vocabulary, right? Those suckers are little things of sugar that make you now you come out and throw all the way back package as the same exact thing. If you look at it and it's in somebody's guy, you're like, ooh, I will eat that. Right? You're just eating rock crystals. Sugar. Another thing that we already know is solids, liquids, and gas. S, L, and G. Those are going to be just examples of physical changes that you were already taught. Or what did you call this in middle school? Say it starts with a P. Nah, well, look, I'm helping you out. What is that? There you go. That's it. Phase change. Right? Solid, liquid, and gas is a phase change. Absolutely. So the solids we need to know, because this is a quiz question, knowing the difference is going to be tightly packed. Okay. The atoms or molecules vibrate in place. And we're going to talk about that. Believe it or not, all atoms and molecules are vibrating. Now, what we do need to know is that solids have a definite shape and volume, meaning they cannot be compressed. Meaning that it cannot be compressed. Two more vocab words, and I promise I will leave you alone for the day because this is a lot of writing. Liquids. Liquids are going to take the shape of its container. Right? So if I have a liquids also are going to have what we call a definite volume. Like I know exactly how much it is, meaning that it cannot be compressed. It cannot be compressed. Now, later on, I would say things like definite volume and they cannot be compressed. We also say in chemistry that they have an indefinite shape. Why? Because it takes the shape of the container. Right? You can make a liquid whatever shape you want, but you get what container. And then the last one, and then we can just relax and get ready for our next class, is gases. Gases are unique because they fill the entire container. Right? Like what size, how big is that container? The volume is going to fill that whole entire container. Those gas molecules are going to bounce around everywhere. Also, we say that gases have a indefinite shape because they take the shape of any container and they have an indefinite volume, meaning that it